So in the last video we looked at waves as a way of transferring energy without transferring matter. Okay, so what happens then when a wave hits a boundary between two materials? What do we mean by a boundary between two materials? So for example, the boundary between glass and air, which is like like a window, for example, or the boundary between air and water. So the surface of a swimming pool or a pond or something like that. What happens when a wave hits that surface? So it can do one of three things. It can either be reflected, it can be transmitted, or it can be absorbed. So if it's transmitted, okay, that means it's just going to go straight through the material. Okay, so that's what we mean by transmitted. It will just carry on moving through the material, and it might be refracted, which is another video. If it's absorbed, then it's going to increase the energy stored in that material. So for example, a black object absorbs light. So a black object, if you put it out in the sunshine, then it will get very, very warm compared to a white object because it's absorbing all of the radiation, all of the light that hits it. Which is going to cause it to increase its thermal energy stores. So let's have a look at two types of reflection. Let's start by looking at the type of reflection you get from a mirror. So a mirror is a smooth surface, an example of an object with a smooth surface. So if I shine a ray of light, okay, I'm just going to represent a ray of light with a straight line like that. If I shine a ray of light at the mirror like that, then it will be reflected. Okay. Now, in order to work out what's going to happen, I need to draw a normal. Okay, now a normal, as the name implies, is just a dashed line normal to the surface. By that I mean at 90 degrees to the interface or the boundary. Okay, so between the mirror and the air, that's where the ray is going to hit, and I'm going to draw my normal where the ray of light hits the mirror, and it's going to be normal to the mirror, or 90 degrees to it, perpendicular. Okay, now I'm going to draw my reflected ray at the same angle as I drew, well, the same angle to the normal as I drew my incident ray. Okay, and this is my incident ray, and this is my reflected ray. There's one very simple rule, and we'll look at this in a minute. But the simple rule involves two angles. Firstly, it involves this angle, the angle between the incident ray and the normal. This is our angle of incidence, and it also involves this angle here. So the angle between our normal and our reflected ray, this is our angle of reflection, as you might have guessed. Okay, so this follows one very simple rule. Okay, now our simple rule just says that the angle of incidence is exactly the same as the angle of reflection. Okay, so our angle of incidence is the same as the angle of reflection. That's our simple rule. Now for a rough surface, it doesn't, well, it works in exactly the same way really. Okay, if I shine a light ray, say here. Okay, so there's my light ray. Now if I zoom in on the surface, I need to draw a normal to that surface. Now the surface is here, so if I draw my ray normal to it, if I draw my normal to it like that, and it will look like that. My reflected ray is going to bounce off at the same angle like that. Let's draw another ray of light. Let's do one here. If I draw my ray of light here, and I zoom in on the surface here, then that's my surface, so my normal is going to be 90 degrees to that, and my reflected ray is going to be up here. Okay, let's do one more just for good measure. Let's do one here. Okay, drawing my normal to the surface. That's probably not there. More like that, I would say. Draw my reflected ray. Notice that all of the reflected rays are at different angles to each other. Okay, so light hits the rough surface and is reflected at various angles. Okay, so this is gonna cause something called diffuse reflection. The rays are scattered once they hit the mirror, once they hit the surface. Yeah, so in a mirror, mirrors appear shiny because they do something called specular reflection. Okay, all of the rays are going to bounce back at the same angle. It doesn't matter where it goes; it's always going to bounce back at the same angle. So it's all going to be uniform. You're going to look at the mirror and you'll be able to see your reflection. It will appear shiny, and so on. However, with a rough surface, because all of these rays that are bouncing back are scattered in various different directions, it's going to do something called diffuse reflection. You wouldn't be able to see your reflection in a piece of paper, for example. A piece of paper does diffuse reflection because it's a rough surface. You won't be able to see your reflection in it. It doesn't appear shiny, but if you've got a white piece of paper, it clearly does reflect light. Okay, it just doesn't reflect it in a specular way. You can't see your reflection in it. Okay, it will appear rough, it will appear matte, and it won't be shiny. Okay, right, that's reflection. I will see you in the next video.